This is a screencast with a related rate example. This one, a car chase. Let me read the problem to you. A police SUV is chasing a car through the countryside heading south on a straight road when the car makes a 90-degree turn left at an isolated intersection, now headed straight east. At the moment that the SUV is 0.6 miles north of the intersection, the car has traveled 0.8 miles east of the intersection, and the police officer's radar measures the distance between the two vehicles to be increasing at a rate of 20 miles an hour. If the SUV is traveling at 60 miles an hour, how fast is the car traveling? Let's draw a picture and identify some variables. So we have the SUV driving south on a straight road. The other car had been driving on this road too, but it took a left. And now is heading straight east. Let's put the SUV here and the car here. And let's call the distance between the SUV and the intersection S, and the distance between the car and the intersection C. We know at the moment that the SUV is 0.6 miles north of the intersection and the car is 0.8 miles east of the intersection. The radar gun tells us that the distance between the two vehicles is changing at a rate of 20 miles an hour. So if we write S, C, and H as our distances, where S is the distance the SUV and the intersection, and C is the distance between the car and the intersection, and H is the distance between the vehicles. We know these distances should be represented in miles because the problem states all distances here in the units of miles and speeds in units of miles per hour. We also know, as mentioned, the distance between the cars is changing at a rate of 20 miles an hour. And we know that the speed of the SUV is 60 miles an hour. But here's something you need to be careful of. S is the distance between the intersection and the SUV. The SUV is traveling toward the intersection. So 60 miles per hour is the velocity of the SUV. But this distance is decreasing. So the derivative of S is negative 60. Not positive 60, negative 60. And dc dt is what we're looking for. We need an equation that relates the variables that we have here in a way that allow us, through implicit differentiation, to get an expression for the derivative of h, the derivative of s, and the derivative of c. Looking at our picture, you can see there's this triangle here that's a right triangle. And you should see pretty quickly that the Pythagorean theorem is an expression that we can use in this case. H squared equals s squared plus c squared. It's an equation that involves all the variables we're interested in, and when we implicitly differentiate, it'll give us expressions for these derivatives. So let's start on a new clean screen. So simplifying things, we get 20 equals negative 36 plus 0.08 dc dt. Adding 36 to both sides, I get 56 equals 0.08 dc dt. And dividing both sides by 0.8, I believe I get 70 is dc dt. And so that gives us our final answer. This shows the car is traveling It's 70 miles per hour. And that's the answer. And that's the end of the screencast. Keep practicing.